Okay, this is my final example. Determine the coefficient of x to the 4 in the binomial expansion of 1 minus 2x over 1 plus 3x all squared. Now, expanding 1 plus 3x squared is not bad. We can actually expand it easily enough. But we would have to then do long division, right, of polynomials. We would have to take the 1 minus 2x and divide it by this expanded. So another way though that we could do it is, instead of doing a division, we could rewrite the question so that we're doing a multiplication. So this is actually 1 minus 2x times 1 plus 3x to the negative 2, right? Using our knowledge of indices, we can bring this up to the numerator, which means the power is going to change from positive 2 to negative 2. And then we would expand this using the binomial expansion formula and multiply the terms by 1 minus 2x. Right, so we could expand this up to a point and then multiply the terms by 1 minus 2x. So if you want, you could start from the constant, go to the x term, then the x squared term, then the x cubed term, then the x to the 4th term. And that would be okay. But we could do a little bit of reasoning, which would allow us not to have to do all those terms. So let's see if we can reason this out. When we expand the 1 plus 3x to the negative 2, whatever terms we get from it will be multiplied by 1 minus 2x, right? So we're going to distribute. So the 1 will multiply all the terms. The negative 2x will multiply all the terms. Now the question is asking us only for the x to the 4 term. That means after we do the expansion of this up to the x to the 4th, and then we do the multiplication by the 1 minus 2x, we're going to have a number of terms, including x to the 4, and we would ignore all the other terms except the x to the 4 terms. Right? And that's fine. But we could, as I said, do some reasoning and get to the x to the 4 maybe a little bit quicker, right? Without having to expand this so far or having so many terms needed from this. Okay, so let's look at it. We have a 1 here, which is a constant, and it's going to be multiplying the terms over here, the expansion of this. Now, since we only want the x to the 4 term and we would be ignoring everything else, what we can do is to ask ourselves, what would the 1 have to multiply from this to get an x to the 4 term? What would a constant have to multiply from this expansion to get the x to the 4 term? And I'm hoping you're saying an x to the 4 term, right? A constant would have to multiply an x to the 4 term to get an x to the 4. Good. What about the negative 2x? What would the negative 2x have to multiply from this expansion to get an x to the 4 term? I'm hoping you're saying an x cube term. And you'd be correct, right? Because this is an x, and the only way to get the x to the 4, it would be that it is multiply x cube. It must be multiplying x cubed, right? So negative 2x times the x cubed term from here would give us x to the 4. So basically, all we need are the two terms from this expansion. We need the x cubed term and the x to the 4th term. All right, so that's what we're going to be looking at. Now let's use the second formula we learned, because our power on our binomial is not a positive integer. It's an integer, but it's negative. And so we're going to use our second formula. So I'm going to copy and paste that second formula. All right, so this reminds us of the formula that we need to expand 1 plus 3x to the negative 2. Now I only want the x cubed term and the x to the fourth term. So I can ignore the 1 plus nx plus n minus 1 and so on. All I need are the x cubed terms, right? So I'm going to say, all right, so for the 1 plus 3x to the negative 2, the x cubed term is, following the pattern, it would be n times n minus 1 times n minus 2 over 1 times 2 times 3, or in other words 3 factorial, times the 3x cubed. Remember, this is 3x and not just x. If it were just x, then it would be times x cubed, but it's 3x, so it's times 3x cubed. And we can work that out on our calculators, giving negative 108 x cubed. And then for the x to the fourth term, again following the pattern, n minus 1, n minus 2, n minus 3 over 4 factorial, or in other words 1 times 2 times 3 times 4, times the 3x raised to the fourth power. Good. And then let's put them with the 1 minus 2x. So therefore 1 minus 2x times negative 108 x cubed plus, so we're ignoring the other terms. We don't need them because the question asks us specifically for the x to the 4. So we would have had an 1 plus an nx plus an x squared term, but we're ignoring those because we don't need them based on what the question has asked for, right? So for this expansion, we only needed the x cubed term and the x to the fourth term, so that when the 1 multiplies the x to the 4, I get an x to the 4. And when the negative 2x multiplies the x cubed, I get the x to the 4. So let's distribute. I don't even need the 1 to multiply the x cubed. I can ignore that because that's going to give me an x cubed term. So it's just 1 times the 405x to the 4, which is 405x to the 4. And then the negative 2x times the negative 108x cubed. That will give me positive 216x to the 4. And I can also ignore negative 2x times the 405x to the 4, because that would give me an x to the fifth term, which is not required for the question. So what we do now is to just add these, and we end up with 621 x to the 4, which means the coefficient that they have asked for is 621.